Hello and welcome to my channel. In this tutorial, we are going to be looking at creating maintainable end-to-end tests using Cypress. The application under test will be a very simple to-do application, which we will create from scratch using vue.js. Let's get started! As usual, we are starting with a minimal vue.js application in a single HTML file being served on port 8080 by live server npm package. If you want to see how to use it, please take a look at my previous video about creating an application layout component with vue.js. You will find the link to that episode down in the description. Our to-do application will consist of two main elements: a form for adding a new to-do and a list of to-dos. The form for adding a new to-do will emit the add to-do event when the to-do is ready to be added. We'll handle that event in the to-do method of our application. The list of to-dos will expect an array of objects that will represent individual to-dos. It will also emit two events, one for toggling a to-do between completed and not completed state, and one for removing the to-do from the list. Let's define the template of the form for adding a new to-do. It will be a very simple template containing just one input and one button, all wrapped in a label for the user to understand what it is for. When the button is pressed, we will call a method that will eventually emit the add to do event. Now that we have the template, let's define the component. In the data, we need to define the text that was bound using vmodel to the input. For the final touch on the component, we need to define the method that will be fired when the user clicks on the button. It will do two things: emit the event and clear the text so that the next to-do can be added. The next component is obviously the list of to-dos. It will be based on a simple unordered list containing a list of to-do items. Furthermore, we're going to bind the individual to-do item to the to-do property. And last but not least, we're going to bind all the listeners for the list into the individual to-do item. This way, we don't need to do manual bubbling of the event listeners, and since the list itself doesn't emit any events, we are all good. The definition of view component is probably the simplest one ever. Just define the prop with to-dos as an array so that we can iterate over it in the template, and we're done. The last component is the individual to-do item. It will be rendered as a list item. We'll have a class to-do and a class completed if the to-do is completed. When the item is clicked, we will emit the toggle event passing on the given to-do so that it will be easier to implement the event handler. Let's put the text of the to-do in a span with class to-do text for easier identification in the test later on. What's left is a button for removing the to-do, which will emit the remove event. For identification purposes, we will use the data test attribute just to show you that there are more ways of selecting elements than just through classes and IDs. The component definition for the to-do item is also very simple. It just has a single required prop called to-do of type object. Let's wire it all up in the application component. First, we need a list of to-dos, which will be an array. By default, that list will have just a single to-do stating that we need to implement the Cypress tests. Obviously, it will not be completed yet. Then, we need to create the handlers for manipulating to-dos. The add to-do handler will receive the text of a to-do and push a new element into the array. Since the to-do item needs an ID, let's find the max existing ID and increment it by 1. By default, newly added to-dos are not completed. The toggle method is as simple as toggling the completed property on a to-do. The reactivity system will do all the heavy lifting for us. Well, removal of the to-do is also quite simple. Instead of playing with locating an element, we will just create a new list and filter out the one element that we want to remove. Done! Now let's see if the application works as expected. Well, we can add a to-do, we can remove a to-do, but when we try to toggle it, there is no visual feedback to show that the completed state has changed. To help it, let's define a style for to-do class to show a pointer cursor, and for completed to-dos, let's show their text with a line through. Now that is much better and clearly shows that the application works. Let's get to testing. First thing that we need is an npm project that has Cypress installed as dependency. You could also install Cypress globally, but I strongly recommend to make it part of your project. Reason for it is that in environments such as continuous integration, you will have full control over which version of the framework will be used. This is just one of the best practices you should follow every time your project requires some external library, not just with Cypress. When Cypress is installed as a local package, its executable file, as in the command it provides, will be installed in the node modules/.bin folder. Accessing it every time through the node modules is quite cumbersome, but luckily for us, there is a better way to do it. When running command scripts, the node modules.bin folder is added to the path. It also creates additional documentation for your project, so that when someone else opens it, they will know what's available right away. Running the Cypress:\open command in an empty project will conveniently create the entire project structure for Cypress with some example tests and even with some example fixtures. For us, it's a little much, so let's remove what we don't need. Having that clean project, let's create our first specification named conveniently todos.spec.js. Now this step is not required, and if you're following this tutorial in a simple text editor, it won't do you any good. However, if you're in Visual Studio Code like I am, it will help the IDE to know the types of elements and global definitions, making it much easier to work with. As with any type of testing framework in the JavaScript world, we have a few commonly known methods for defining the structure of a test. One of them is describe, which just groups test cases. The other one is before each, which will allow us to run some code, as the method suggests, before each test. We will use it to navigate to our application. Since the app has no storage, it will always be in a state where there is just one not completed to do. Now we are ready to create our first test case. The it method, which stands for integration test, will try to check if we can create a new to-do. The sci.get method grabs the element by a CSS selector and then allows us to do something with it. In our case, we will first grab the input field, clear it, and enter some text, which will be the content of our new to-do. Then, we will grab the button and click it, which will trigger the add to-do method and create a new entry in the to-dos array. No test is valid unless there's a verification of the state after the test action has completed. So, we will grab all the to-dos on the page and expect that there are two to-dos. The first one is always there after we have navigated to the page, and the second one is just what we have just created. Again, please note the IDE is very helpful when typing. This is all to the reference XML comment at the top of the file. To run the test, we need to click on the todo-spec.js in Cypress, which will open the runner in a currently installed version of Chrome. Please note the miniature version of the browser is actually an iframe, which makes it fully interactive. On top of that, we can see a history of operations to the left, and when hovering over those actions, we can see a snapshot of how each step has interacted with our to-do list, before and after, for example, for clicks. It's very convenient for figuring out why tests are not working. It's not hard to notice that the sci.get method that accepts CSS selector can be very overused throughout the tests. It is also very hard to write maintainable tests this way, which will be easy to update once the structure of the application changes. There are a couple of ways to overcome that. One would be to create consts with the selectors. That will work, but it won't help the fact that we are still directly using the Cypress API, which shows no structure of the application. As a result, the test is very synthetic and hard to understand. A better method is to introduce the concept of components in test. Each component in the test will essentially wrap a component of the application and expose its elements and actions as properties and methods. Let's see how that works. We will start by creating a base class for all components called a wrapper. You could also call it component if you want. However, for the purpose of this demonstration, we will try to keep in mind the fact that classes inheriting from the wrapper are in fact wrapping some existing components of the application. Now here is the most important part. Instead of finding an element each time, we will create the concept of root element, and we will search for all the dependent elements from that root rather than selecting them globally. To implement it in Cypress, we need to give each instance of the component a unique ID, which will be best done using the UUID library. To get the root element each time we need it, we will just call the site.get method with that ID prepended by an @ sign. To let Cypress know which element it actually is, we can alias it using the as method on the passed on root element. Done! We now have all the base for creating quite sophisticated wrappers for our components. Let's start by creating the wrapper for the form for adding new to-dos. It has an input field for entering the text and a button for triggering the add to-do event. Now creating the add to-do method is as easy as referencing the input, typing in the given text and clicking the button. Pretty neat, right? The next wrapper we need for our test case is the list of to-dos. It is even simpler because it just needs to give us the information about existing to-dos. Please note it is very different from just referencing all the to-dos on the page because it is scoped to the to-dos div. Of course, we could have done it with the site.get method previously, but the usable length of selectors, I mean in terms of understanding them, is quite limited. Essentially, the closer to the actual definition of the component, the better. Now, there is something wrong as we can't seem to get any code completion for the to-do list. It should have been a Cypress interface, but it is more like an Any that we would expect to be. This is a common mistake that happens when we don't return a value from a getter. The fix is easy and once again shows that having IDE support when writing code is a great time saver. In addition to the previous test implementation, we can now easily check the number of to-dos before we add one and after we added the one. It is also much easier to understand what the test does just by reading the code. In the log for our test, we can easily see the UUIDs of wrappers and when they are being utilized. A little bit of cleanup, and we can write the next test. This time we will see if we can remove a to-do. Please note the reuse of wrappers here. We want to lean on the data created in the test rather than some pre-existing state. It is not always 100% possible, like in the case of the number of to-dos in the list, but the more the test is independent of the pre-existing state, the more resilient it is to change. Since the new to-do is always added as the last one to the list, it'd be great to have a method for retrieving it, like let's say get last to-do. Conveniently, there is a last Cypress method that can return just the right element. To help the test be more readable, we write the to-do item in yet another wrapper called to-do item wrapper. If you remember, the to-do item consists of a text and a button to delete it. Having that wrapper, let's implement the remove method. The last test is about toggling a to-do state. Again, reusing the wrappers, let's create a new to-do. Using the root element, which is also available in the test, let's check if the to-do is completed or not. This means that we are inspecting the public API of the to-do item component to check its state. If possible, always operate on the public API instead of digging deep into the implementation details. That makes the test more resilient to change if the implementation details change. The toggle method should be very easy to implement. Essentially, we just grab the text, click on it, and we're done. If you look at the test, it is clearly visible that the checks and the toggle method operate on two very different levels of abstractions. This is not wrong from a technical perspective, but inducing a strain on the brain of the reader, which needs to do context switching between different levels of abstractions, is really not a good thing. To change that, let's define two methods that will check if the to-do is completed or not. Now the test is really readable, but what is immediately visible is that we have huge code repetition. The to-do list getLastToDo method gets called over and over again. We can fix that by making the expectations and the toggle methods chainable by returning this. Now, this looks like proper Fluent interface and also clearly signifies that what we are working on is the same to-do item throughout the whole operation. One of the last things that is wrong with those tests is more repetition, this time in the form of instantiating the wrappers in each test. We can mitigate that by moving it to the before each callback. However, it is worth noticing that the variables will now need to be declared outside of the callback to be accessible in both the before each and our tests. This also means that Visual Studio Code will have no way of knowing the types of the wrappers, and the nice experience of code completion would just go away. Thankfully, Visual Studio Code understands the JS docs type annotations. Now our tests are dry, easy to understand, and provide enough facilities to write even more clear and readable tests, which are easy to maintain. Okay, that's it for today's video. If you found it interesting, give it a thumbs up. Remember to subscribe to not miss any new tutorials and click that bell button to get notified when new content is available. Till next time, bye bye!